Good morning, all. Myself, Krishna, and today we are going to talk about linear regression. This is one of the algorithm which coming under regression, which is part of supervised machine learning. So in machine learning, you can see number of algorithm we are choosing to train our data set. So if we have classification and regression that I mentioned in my previous videos. Those are part of supervised machine learning. And in classification, you can see number of algorithm. Mostly they use KNN, random forest, for better accuracy, SVM, logistic regression, and name pair classifier. Similarly, for uh, regression, you can see linear regression. It depends upon your data set, what how it appears. So whenever you get large data set, try to uh, take a small chunk and see and try to draw this data, how you are getting the graph, and based on the outcome, you decide what exactly you are trying to achieve here. So in this regression, you can see we have linear lasso, polynomial, SPM, and few you can see SPM random forest you can use in classification as well as regression. Similarly, for clustering, you can go with k-mean, and k-mean is widely used for clustering. We have others like hierarchical test clustering, deviation, and association. We have a priori and eclat algorithm. This I already spoken type of parameters. We have two types, model parameter and hyperparameter. So this W weight and bias is model parameter. I already um, explain all those information in detail in my previous video. So if you can watch, you can get this idea. What is model parameter? What is hyperparameter? So whenever you get your data set, we need to find out best fitment value for the weight and bias so that our loss function should be minimum. Yeah, that could the point we used to get, that is global minimum. So to define global minimum, you need to take assistant of hyperparameter, where at some point you will start and step by step you see the outcome of your cost function. And this could be random value initially. And this step you can see that we call learning step. Um, so the point you started, that we call random initial value, and here this is the minimum. You can't go. Um, um, this is threshold. I mean, you can't below of this point. So this is the point where we have minimum cost function. So this weight we are going to put and bias we are going to take. This is one of the concept which we are using to for model optimization. This is widely used. So in any of the algorithm, if we are talking, gradient descent will come to picture. This all I already explained. This bias variance data I talked in my previous video, where uh, here we are just checking which point we are having higher bias. Yeah, the concept of overfitting. So in today video, we are stick to linear regression algorithm. So I will show you some data set, and we'll see how we are going to calculate weight and bias. So if we know, like generally for the linear regression, like I said, If you can draw the line, it will be like this. At and Just think if this is your data set, it comes like this. So what we need to do, we need to uh, l- draw some line like this. And if we know like y is equal to mx plus c, in machine learning, we used to call wx plus b. So this is weight. So if we get this formula, if we get the uh, best fitment for weight and bias, the x we are going to have at every data point. So we can calculate this y. Okay, so just take any of the data like at the age of 20, maybe your salary is 40K. At the age of 60, your salary is at the age of 25, your salary is 60K. And at the age of 70, at the age of 25, your salary is 70K. So if at some point, if we get this weight and bias, we are going to get the age, we can calculate the salary. So this is what we are going to do, and y is equal to mx plus c. But if we are having multiple features, then we are going to use this like this. So we can come here and see how things are working. So just think this is my salary data set, and Mm. let me print this salary, how what we are getting. So right now I'm not printing anything. I just want to print this. Okay, and we'll see what we are getting. This also we can. So it is going to give us shape and head. Um, so so this will talk about this data. We have 30 different uh, lines and two uh, column and 30 rows and column. So here you can see this is in this data uh, year or years experience and salary is here, right? So if you want to see if you want to draw how it looks, you can draw like this. And just let me draw. One point I'm just thinking, you need to do some data imputation if you remember, like just to find out if there is any null value, yeah, anything is missing. Then we used to follow data imputation. So we can use this, disable this one. So this point is for data imputation where we are checking if there is any null value in the salary data, because if that is nullity, it won't make any sense of we need to remove those data. And this is for holding X and Y, like I told you. Um, if this is your X, this is Y. So what X is, so we are going to calculate salary against age. This is what we are doing here. So X is here we are just taking X and Y. And if you can plot this one, how it looks, you can see. Mm. So you can see our data is like this. So if our data is like this, it means we need to go with linear regression. Okay. If something fall coming like this, then we need to go with logistic regression. So before picking any of the algorithm, we first try to draw um, how this how you are getting the plot. So in this picture, you can see it is looking linearly. So if we can find out best fitment for y and x probably, we can draw this one. We can calculate salary against age. So now we have x, y, and if we need to we need to get trend test data. So we have this method for trend test. So here we are taking size for 30 and 70%. So your data test will have 30% and training you are doing for over 70% of data. And once your model is defined, we are going to use test data to find out accuracy. This could be any value. If you are putting dot 4, it means 40% for the test size and rest 60% for the training size. This random forest is a static value. You can define anything. The reason behind keeping true, if I'm trying again, giving true, it will give me same set of data. And if you want to shuffle new set of data, you can change this value. So here we are going to have 10 test data at this point, and this is my model. Some people used to write, if you have Python expertise, you can write the logic for linear regression. But since we already have the library, better you can call this model and uh, try to get. And we can use a number of model here. Like here we have linear, you can use model for logistic, you can use all the model, random forest, KNN, and then you can find out accuracy, which model is giving you more accurate. So in my subsequent video, I'm going to talk everything in details. So once I will get model object, I need to find this training data first. And at this point, I'm just supplying training. And once uh, uh, I get, I'm checking the value of weight and bias. Uh, so just see what we are getting here. So here we can say, based on the given data set, this is the right weight where uh, and this is the bias. So if we are using y is equal to mx plus c, where m is weight here and c is bias, you can calculate salary if age is given. Now, other point, since we already kept the test data, we can use here test data prediction. I can remove, I can uncomment this. Okay, and save. So you can see my test data prediction. Like I said, if I get 100 records, 70 record I use for training my model and 30 records I kept for testing my models. So here at this point, you can see whatever data I kept for test. This is what we got the salary here for the given age. So this we got the salary through my model, right? Uh, through my model, I got this salary. But uh, just think this test data will have already salary, right? Because we have both the things. So then we can figure out uh, f- the differences uh, in between model prediction and actual salary and see what is coming up. So here we can draw the line. This is X test, Y test, and this is X test data prediction, color blue. So blue is my predicted data, and red is my actual data. And just we can plot it and see how this is working. So you see the point here. Uh, the 30% data is test data where we have agent salary, and we use linear regression model where we get this weight and bias, and we have test data prediction where we predicted salary against age through my model. Now we can see the difference, how it is, what it is coming. So if you see, this blue line is my predicted data and red line is the actual data. So if you can see, it is more or less, uh, it is this is my data and this is the actual here. You can see slightly change, slightly uh, deviation here, but overall you can see this is my predicted data and this is the actual data, and you can find out accuracy and all. So I in my next video, I when I will go with logistic regression, I will be trying to find out the accuracy and all. So for now, it's fine. I will be catching tomorrow with some new video. Thank you very much. Bye bye.